Hey everyone, and welcome. Today we're going to pull back the curtain on something that pretty much powers our entire digital world, the OSI model. The best way to think about it? It's like the ultimate digital postal service, this amazing set of rules that make sure your data gets exactly where it needs to go every single time.
I mean, think about it. It's something we do every single day without even blinking. You tap an app on your phone and boom, information just zips from your hand across who knows how many networks to a server halfway around the globe and then all the way back. So how on earth does that incredibly complicated journey happen so perfectly, so fast?
Well, the secret sauce is this really elegant framework, the OSI model. It's the universal rulebook that every single device, every network, and every piece of software agrees to follow. What it does is take this massive, mind-boggling task of global communication and break it down into 7 clean, manageable layers. So here's our game plan. First, we'll talk about why we even need a universal rulebook like this. Then we're going to take a trip through all 7 of those layers. After that, we'll connect all this theory to the real world of wireless tech. And finally, we'll wrap it all up and see why this model is just so important. Okay, so let's start with the big, obvious question. Why even have a standardized model? Why couldn't every company just, do its own thing? Well, it's pretty simple, really. For global communication to actually work, everybody has to be speaking the same language. A standard model makes sure that a device made in one country can talk to a server in another without any issues. It gives engineers a common blueprint to work from, and maybe most importantly, when things go wrong, and trust me, they do, this model gives us a logical roadmap to figure out exactly where the problem is. All right, now for the main event. We are going on a journey through the 7 layers of the OSI model. We're going to start right at the top with the app you see on your screen and travel all the way down to the raw electrical signals that are literally pulsing through a wire or flying through the air. And here they are, all 7 of them, from top to bottom. You might have even heard some funny mnemonics to help remember the order, but we're going to do more than just memorize names today. We're going to really dig into what each of these layers actually does. So let's kick things off at the very top. Layer 7, the application layer. This is the one you actually see and touch. It's your web browser, your email, that YouTube app you're probably watching this on right now. This is where your data's entire journey begins. From there, your data gets passed down to layer 6, the presentation layer. Just think of this one as the universal translator. Its job is to get the data ready for travel, making sure it's in the right format, encrypting it for security, and even compressing it to make it a little smaller and faster to send. Next up is layer 5, the session layer. This is the dialogue controller. It's in charge of opening up a communication channel, keeping that channel stable for the whole time you're connected, and then closing it down properly when you're done. It basically manages the entire conversation between 2 devices. Moving down to layer 4, we hit the transport layer. I kind of think of this one as the quality control manager. Its #1 job is to make sure your data gets to its destination reliably and in the right order. It uses protocols like TCP to check for errors and make sure nothing gets lost along the way. Or, for something like a live stream, it might use UDP, which is all about speed over absolute perfection. Layer 3 is the network layer, and honestly, this is the GPS for your data. This is where your little packets of data get their address stamped on them. You've heard of it, the IP address. This layer's job is to figure out the best possible path for your data to take across the huge, tangled web of the internet. We're almost there. At layer 2, the data link layer, we're getting really local. This layer deals with the physical hardware address, the MAC address. It's kind of like putting your data into a specific, correctly addressed envelope just for the local mail route, making sure it gets from your router to your specific computer. And finally, we've arrived at layer 1, the physical layer. This is where the digital stuff becomes, well, physical. This layer is what takes all those ones and zeros and turns them into actual electrical signals, flashes of light or radio waves that travel through copper cables, fiber optics, or just plain old air. All right, section 3, from cable to airwaves. Okay, so we've gone through all 7 layers. But how does this abstract model actually apply to the tech we all use every single second? Wireless communication. It's one thing to picture data in a cable, but how does all this work with 5G or your home Wi-Fi? Well, when it comes to wireless, the physical layer is where all the magic happens. This is where incredibly clever technologies like OFDM and MIMO come into play. They're responsible for shaping the radio frequency signals that actually carry our data through the air. You could say this layer is the absolute bedrock of any wireless system.
And sitting right on top of it, the data link layer acts like an air traffic controller. You know, the airwaves are a busy, crowded place, and this layer's job is to manage all that chaos. It handles scheduling, deciding whose turn it is to send data, so that everything flows smoothly without signals crashing into each other.
And this table right here, this is where it all clicks. Look how perfectly the model maps to what's happening on your phone. At the very bottom, the physical layer is the radio tech itself, OFDM, MIMO. Just above it, the data link layer is managing the traffic with MAC scheduling. The network layer is still using IP addresses to route you to the internet. The transfer layer is using TCP or UDP for that video stream, and right at the very top, the application layer is the YouTube app itself. It's the same exact stack, just happening over the air.
So, after all that, let's bring it all home. Why does this model, which is decades old, still matter so much today in our super-connected wireless world? So what's the big takeaway here? The OSI model isn't just some dusty old theory. It's a powerful way of seeing things. It lets us understand the entire communication chain, from the app on your screen to the radio waves in the air. For engineers, it's a critical tool for designing new systems and fixing broken ones. And as we've just seen, it's the perfect bridge between abstract ideas and the real-world tech we use every day, like 5G and Wi-Fi.
So if there's one key thing to remember, it's this. While every layer plays a part, the future of wireless communication is really being built at the very bottom of this stack. Mastering the physical and the data link layers is what unlocks all the amazing potential of things like 5G and beyond. It really makes you wonder, what's the next big breakthrough at these fundamental layers going to be?